In 2005, a team of astronomers scanning the darkest edges of our solar system spotted a faint, icy sphere. It was Eris. Eris sits in the scattered disk, a sparsely populated ring of icy bodies stretching far beyond Neptune. During the early solar system, Neptune migrated outward. Its massive gravity disrupted these smaller bodies, flinging them into wild, elongated orbits. Finding Eris proved that the outer boundary of our cosmic neighborhood is an active, chaotic graveyard of these gravitational outcasts, rather than an empty void. Eris has an orbital eccentricity of 0.44, deviating severely from a perfect circle. This yellow path stretches far outside the inner planet's horizontal plane. This massive, tilted loop takes Eris 557 Earth years to complete one trip around the Sun. When astronomers first measured this distant object, the data revealed something unexpected. Eris was roughly 1,445 miles across, almost exactly the same size as Pluto. For decades, Pluto had held its status as our 9th planet. Now, astronomers had found a body of equal size orbiting even further out, raising an immediate logical problem. The astronomical community faced a direct crisis. If Pluto was considered a true planet, this strange new outcast had to be classified as one too. To resolve this, the International Astronomical Union convened in 2006. In this room, scientists voted to formally rewrite the rules governing what objects in our solar system are actually called. This graphic breaks down the newly invented category, the dwarf planet. To fit this classification, an object must orbit the Sun and be round, but crucially, it fails to clear its orbital neighborhood of other debris. By adopting this exact definition, the voters reclassified Pluto. The beloved 9th planet was officially demoted to dwarf planet status. The discovery of Eris forced this exact issue to the surface. Its mere presence dismantled a planetary model humanity had accepted for nearly 80 years. But the debate over categories distracts from the physical reality of the object itself. Eris has its own small, dark moon, named Dysnomia. By observing how Dysnomia orbits its parent body, astrophysicists can apply standard mechanics to calculate the exact mass of Eris. Looking at this mass comparison chart, the results are clear. Even though the two bodies are similar in physical width, Eris is 27% more massive than Pluto. Its dense, rocky interior packs significantly more material into the same amount of space. Eris stands as the undisputed heavyweight of the outer dark. Today, Eris is near its aphelion, its maximum possible distance from the Sun. At over 9 billion miles away, surface temperatures plummet to a staggering -405 degrees Fahrenheit. The cold is so absolute that the dwarf planet's own atmosphere physically collapses. The gases freeze solid and fall directly to the ground as snow. This snow is primarily made of methane ice. It creates a hyper-reflective shell that bounces back 96% of the light that hits it, giving Eris an exceptionally high albedo. Locked in this deep freeze, the surface acts as a perfect, uncorrupted mirror, preserving the chemical history of the early solar system. Zooming out from the present day, that massive 557-year orbit guarantees Eris a unique fate in the deep future. Billions of years from now, our Sun will exhaust its fuel and expand into a massive red giant. It will vaporize Earth and the rest of the inner rocky planets. But Eris is shielded by its extreme distance. As the Sun swells, the dwarf planet's frozen atmosphere will briefly thaw into a gas, right before the dying star permanently collapses into a cold white dwarf. The extreme isolation that keeps Eris on the fringes of our solar system today ensures its survival. Long after we are gone, this pristine time capsule will drift gracefully onward into the infinite, dark, interstellar void.